Welcome to part 8, the longest part of this series. In this video, we focus on automation and transport management. We will set up CI/CD using SAP BTP to automate our deployment process. Then we will look at the cloud transport management and understand how application can be transported across system landscapes. Finally, we will take a short look at the SAP Alert Notification Service to see how we can monitor and react to events in our cloud environment. First, we create a local Git repository if it does not already exist. With Git init, we initialize the Git repository, we add all files, and we commit it to initial commit. Next, we create a new repository on GitHub named tutorial demo. We make it private, or that what you want, and create a repository. We copy this URL and create a remote. Then we push it into the GitHub repository. And here is it. Now we prepare SAP BTP. I will keep this short because we have already performed similar steps several times before. In the global account, we make an entity assignment to our subaccount. Add this, and the plan is default application. And then we go to the subaccount. Yeah, we must save. We go to the subaccount. And create an instance of the service plan. This setup is required only once for a single subaccount. It can be any subaccount, even a dedicated one for CI/CD only. In this example, I use the dev subaccount. Finally, we assign new role collection to the user. The CI/CD service administrator and CI/CD service developer. Later, we need credentials for GitHub. Therefore, we create a personal access token. We're going to GitHub, going in the profile to settings, scroll down to developer settings, personal access token classic, generate new classic personal access token. The name is tutorial demo, and we need this scope. Then we generate the token and we copy the token. After we close this page or leaving this page, we can't see this token. So copy this now. In the next step, we're switching to the CI/CD application. and create a new credentials. Go into credentials, plus, and enter the name GitHub token, access token from GitHub. It's basic authentication. We keep the type basic authentication. Username is our username on GitHub. The password is the copied token. We create it. Next, we create 2 additional credentials. The first one is for the Subaccount. Dev Subaccount. Subaccount demo dev. In username, you can use your normal login details for the BTP Subaccount. And this is our password. You can create a own user for this if you want. Create it, finished. The second credentials is a webhook secret. We give the name webhook, description webhook secret for GitHub, and the type is webhook secret. We generate this and we copy it. We can't see it later, and we create it. And now it's important that you store the webhook secret in a text editor or something like this. I use the PowerShell webhook secret get clipboard, and I copy it from the clipboard directly in the variable. This variable is only stored temporarily, and its content is not visible on the screen. Now we add the repository in the CI/CD application. The name of the repository must exact match the repository name on GitHub. So we go to repositories, open this, and we see the name here and here. And we copy this, or we can write it. Please check if no space before or after the name. The clone URL we can copy from here. Be careful, the webhook secret is no longer in the clipboard. The credentials we choose are from the list is the GitHub token. For the webhook event receiver, we choose GitHub, if not already done, and we choose the webhook credentials. We add them. And if not already open, we open this and copy the payload URL to the clipboard. Then we switch back to GitHub to the repository and open the settings of the repository. And here we choose webhooks and add webhook. We paste the payload URL. The content type is application JSON. And the secret we get from here. The rest of the settings are okay. Add webhook. Now we create a job in the CI/CD application. After this step, CI/CD is fully functional. We enter the name of the job, deployment, deploy MTA project The repository is already set, or you can choose it with this button. Next, we define which branch the job should use. Whether you use main or another branch depends on the transport strategy. If you use SAP Cloud Transport Management or you have a simple sub-account, you can use the main branch. In this scenario, CI/CD is only used to deploy to the dev system. All further transports are handled by CTM, the Cloud Transport Management. If you use Git-based transport management, the branches should reflect the system landscape. The branch dev deploys to the dev subaccount. The branch QA deploys to the quality subaccount, and the branch main deploys to the production subaccount. In this case, CI/CD deploys directly into the corresponding system. This approach has many advantages and is recommended by SAP. We will discuss this later. The pipeline should already be selected correctly to Cloud Foundry environment. For configuration mode, we choose Job Editor. Otherwise, the process would be defined in a configuration file inside the Git repository, similar to GitHub Actions. Under Build, we choose the build tool MTA and choose the build tool version that we want to use. The build tool descriptor is the MTA.yaml. That's correct. We're going to acceptance to deploy to Cloud Foundry space and add one. Here we paste the API endpoint, the org name, and the space. All this we can find with CF target. This is the API endpoint. Make sure that no space at the beginning or the end. That's the org name, and dev is the space name. For credentials, we select the subaccount credentials we created earlier. Optionally, under Advanced Configuration, you can define final comments. These are bash commands executed at the end of the job. I often use a notification service like ntfy.sh to send easy push messages to my devices. With a simple call command, we can send a push notification to multiple devices. I also use this method for manual deployments in the terminal. We create the job. Now we test the CI/CD pipeline. We open the UI5 app and we see version 1. We make a small change in the app. And replace the 1 with a 2. We add the changes to the stage. We commit this UI5 v2 and we push them to GitHub. And now, in the CI/CD app, we will see that the commit is triggered. And we can click it and we see details of the job. This build process and deployment process takes a few minutes, so I will skip the waiting time. After the job, I received a push notification on my device, and we want to check the UI5 app, refresh the app, and we will see we have the version 2. From now on, we can push the changes to the main branch, and the deployment is fully automatically. In this section, I will show the setup and usage of the SAP Cloud Transport Management, also called CTM. With CTM, we can transport changes across a multi-system landscape. This is one of two possible transport strategies. And to be clear, it's not the best one. I will explain why at the end of the video. I already created the protective subaccount using the same process shown in part 2. Allow all IP addresses in the HANA TD settings does not need to be configured for the quality and productive subaccount. This is only necessary for hybrid mode and the dev subaccount. Every app router URL must be added to the redirect URIs in the XS security JSON file. Otherwise, login will not work. Therefore, it makes sense to manually deploy the app once to each system. You can list the organization using cforg. Then we copy the system name and we switch the target system with ZF target O and the name of the organization. If you have only one space, it will automatically select it. Otherwise, you can list the space with CS spaces, and you can change this with ZF target S and the space name. Deploy as usual using mtp build and cf deploy in the mtar file. After deploying, take the app router URL at https:// at the beginning and /** at the end, and add it to the redirect URIs. After the deploying to QS and prod system, we need to configure destination in the subaccount where the CI/CD is running. We create a destination for each target system we want to transport to. The dev system is not a part of these destinations. CI/CD deploys directly to dev. We need only for QS and prod a destination. We create a destination from scratch. The name is the name of the system, destination QS, and it's important to change the authentication to basic authentication. The type is HTTP. Description you can enter if you want. The user is the username, and the password is the password that you use to log in. The URL was described in the documentation of SAP. This is the format. First, we need HTTPS deploy service CF. If you found a documentation with CF apps, this is obsolete. And after this, the domain, SL prod, the org name, and the space name /SLP. You can find the most information using CF target in the terminal. But first we copy this and paste it here. CF target. The domain is everything without API. This is the domain name. This is the domain name because CF is already here. My org is this. And the space is prod. Oh, yeah, prod. In this case, we are on the prod system. And the same, we do the same by switching the target to the QS system. We copy this again. We take the domain. And the organization and the space is QS. This is for QS, and this is for prod. So we're going back to the configuration and paste the URL for the QS. Please be sure that no space in the beginning and the end. And after this, we can create. This checkbox must be set, and we create this destination. After this, we open the destination and check the connection. It was good. Now we create another one from scratch. destination prod, basic authentication. We take the URL from here and paste it here. No space. We create it. You must leave the text box before you can create a. Click the button. This is checked. We going in the destination for prod and check the connection. Everything is good. In the video description, I have a script for the PowerShell you can run, and you can choose your system. In this case, the demo QS, and this creates the URL for you. The same when you choose the prod system, you have the URL and you have it in the clipboard. And important, if the documentation shows deploy service CF apps, this is outdated and will no longer work after April 2026. Simply remove the word apps in this URL. And now we add entitlements for cloud transport management. Add two plans, standard application and standard. Do this in the Subaccount where runs the ICD. We add two service plans to the cloud transport management service. The first is standard and the second is standard application. Then we create a service. First the standard, CTM, and the app. And in standards and subscription, you will see the process. And next, we assign roles. This time, we first need to create a new role collection. This is not automatically created. CTM all. The required roles can be found in the CTM application under Manage Roles. We're going to the application, the 3-point button, Manage Roles, and here we must click on every plus sign and assign them to the role collection we created before. And now we assign this row collection to the user. Then we're going to the instances and subscription again. And we create a service key for the CTM service instance. CTM key. Great. After the creation is finished, we view it and copy the JSON. Now we switch back to the CI/CD app. And here we create a credential, CTM key, description, CTM service key, and here we choose service key and paste the JSON content and create it. And now we switch back to the Cloud Transport Management app. And here we go to Landscape Wizard. In the Landscape Wizard, we choose 2-node landscape. Why 2 nodes? Because staff is handled by CI/CD. CTM is used only for QS and prod. Next, for node 1, we enter the name, QS node, description, QS system. Here we check allow upload to node. Forward mode is auto. Content type is multi-target application. And destination is the destination we have configured in the BTP. To the destination is QS. The same here is the prod node. Prod system. Here we don't need to upload. It's beginning here and goes automatically to node 2. Forward mode is auto. Content type is multi-target application, and destination is the destination of the prod system. Here is the route from node 1 to node 2. Next. Summary. And finish. Before we can use a CTM, we must configure the CI/CD application and the job. We go to the job, we select it, edit, and in release we add a Cloud Transport Management. We select upload to and enter the node name. The node name was QS node. And the service key is a CTM key. We save the job, and now CTM is fully usable. We open the app in the prod system. The UI5 app. When this error occurs, you will not have all needed rules assigned to the user. We're going to the QS system, going to users, and here in the default identity provider for application, you must assign the roles. Admin and user. And the same in the productive system. Oh, we must change it in the default. We must do it in the default identity provider, because that the identity provider for application is just for the launchpad. And now we log out clear cookies, cache, and log in. Important note: the Launchpad configuration must be done in all systems the same way as shown in Part 7. Also, direct URLs for apps and services should be created and documented for each system. Now we demonstrate the transport process. We open the app UI5 app in the QS system. I use a PowerShell script to select the target and generate the URL and open it in the browser. I select QS system. I select the UI5 app, and this error appears. When you get this error message, the reason is that the version with the correct redirect URIs is not yet deployed to the system. But with our cloud transport management, we will import this version. The same problem exists in the prod system. We will open the UI5 app in the dev system. Here we see the version 2, and we make a small change in the application. We increase it to number 3, and then we change it to the Git repository stage and commit UI5 3, and we push it to GitHub. Now the CI/CD job will deploy the app to the dev system, and after this the change will upload to the CTM node 1, to the QS node. We can look at the job. After the deployment, we refresh the UI5 app. When it doesn't work, you can open it again. And we see version 3. And now we go to the Cloud Transport Management app, and we have a pending transport. We go to transport nodes. We select the QS node and go in. And here we have a transport request, and we select them and import selected. This imports the change, the version 3, into the QS node. And now we go to the transport management, go to transport nodes, QS node, and we see we have a transport request. We select the transport, import selected, OK. After importing to QS, it becomes available for production. The full process is: first, commit change it locally. Second, push it to GitHub. Third is the ICD deployment to the dev subaccount. Number 4 is upload to CTM. Number 5 is import to QS. It runs actually. Number 6 is transport to the prod node. Number 7 is import to the prod subaccount. In the transport action logs, you can monitor every step and its status. This is the actual one. If you become an error, please check the destination URL that we have created. That is the reason I have 2 errors, because I'm trying to import to the node. And now the import is finished, and we open the app in the QS system. I select the demo QS, UI5 app, and now it come no error, and we have here the version 3. I go to transport management, transport nodes. I select the prod node, and we have the transport request here, and we can import it here. And when this is finished, we open the UI5 app in the prod system. And log in. And it works, and we have version 3. With this, SAP Cloud Transport Management is successfully configured and tested. Please keep the following points in mind. First, users must have the required role collection assigned in all relevant systems. Second, all redirect URIs for the used system must be maintained in the XS security JSON file. Third, in some cases, you may need to log out, clear cache and cookies, and reload the page or open the URL again due to caching issues. Number 4, trust configuration and destination must be configured correctly. Number 5, the destination URL must not contain ZF apps. Number 6, names can be case sensitive. Always pay attention to upper and lowercase spelling. And number 7, the URL in the destination must be correct. And now I show a little bit about the SAP Alert Notification Service. With the SAP Alert Notification Service, we can send notifications such as emails, Microsoft Teams message or Slack message, and many more. The Alert Notification Service was event-based. This means it is not directly triggered by CI/CD or other actions. Instead, it reacts to specific events that we define. First, we assign the entitlement for alert notification with the standard plan. For the subaccount, we use the ICD. Then we switch to the subaccount, to the marketplace, and create an instance. After the instance is created, we create a service key. Then we open the service key and copy the JSON. We switch to the CI/CD application and create the credentials from type Servicekey. And paste this JSON content. Additional, we store the service key in a text editor because we will need some values from it later. Now we open the job and edit it. We scroll down to send build notification via SAP Notification Service. State on, select the service key and save the job. Now we switch to the BTP and we create a destination to the Alert Notification Service. From scratch, name ordered, type HTTP, description is optional, proxy type internet, authentication is OAuth to client credentials. The client ID is the client ID from the service key, this one. The client secret is the client secret from the service key, this one. The token service URL is the OAuth URL from the service key, this one. And this URL is the URL in the service key, this one. Important, use default client trust store must be enabled. And we create this. We can open it and we can check the connection and it's okay. Now we open the Alert Notification Service. And we create a subscription. The name is deployment. Description is CI/CD deployment. And we create it. Then we create a condition. It's also deployment. The condition is event type is equal to deployment uppercase. We have no more condition. We shows everything what happened when the event type deployment is triggered. We create an action. We select email and you can choose what you want. And the name is me. And for email address, I have created a temporary email account, and I copy this. We don't need a subject template or a payload template. We create this, and we save it. We going to the email account, and we see we have a notification, and we must confirm this. And we're going back to the email account. And now the subscription is ready. So I make a change in the GitHub repository and commit them and push them to GitHub. We make the version to number 4. UI 5 version 4. And we push them to GitHub. And after the deployment to the dev subaccount, we get a mail. Here. I will open the CI/CD app. And showing the job. And on the left side, I have my email. While this is running, we can make a test manually. We open the subscription and we send a test event, but we must change this to deployment, the event type, and send it. And then we going to the email and we get this notification. With the information that we have sent in the test event. It works. We already have received some notifications. Starting of the deployment. In this content, we can see different values that we can use as condition for the subscription. And here is the new notification email for the completed deployment. Event type deployment, operation status complete, and the alert notification service is working. The alert notification service supports many different events. This demonstration shows only one possible use case for monitoring deployments. Transport strategies in SAP BTP. In this section, I will compare the two transport approaches in SAP BTP. First, I will show the transport flow using CI/CD together with the cloud transport management. Then, I will show the transport flow using CI/CD with Git-based transport. After that, we will look at the advantage of CTM and Git-based transport. We will compare the difference in handling and configuration, and finally, I will give a recommendation. Transport with CTM. On the left side, we use Cloud Transport Management. We start with an MTA project and a local Git repository. We push our changes to the remote Git repository. This triggers SAP BTP CI/CD, and CI/CD automatically deploys the changes to the dev system. If the deployment is successful, the artifact is uploaded to the CTM/QS node. From there, we must manually import the changes to the QS system. After a successful import, the transport is moved to the CTM prod node. And again, we must manually import the change to the prod system. We always have to go through the complete transport process step by step. And now the Git-based transport. On the right side, we use Git-based transport. The process starts the same way. We have an MTA project and a local Git repository. We push our changes to the remote repository on GitHub. This triggers BTP CI/CD. The key difference is the branch determines the target system. If we push to the dev branch, the application is deployed to the dev system. If we push to the QS branch, it is deployed to the QS system. And finally, if we push to the main branch, it is deployed to the prod system. The branch strategy directly controls the system landscape. Very simple, no additional transport steps. We only have to configure 3 jobs in the CI/CD with different branch information and different target systems. This means 3 different Subaccount credentials. That's all. And now the advantages. Let's start with the cloud transport management. One important advantage is that it's fully SAP standard compliant. It clearly separates roles like development, deployment, and transport approval. This makes it suitable for audit-driven organizations with strict government roles. It is also familiar to traditional SAP teams coming from classic transport systems. However, there are also disadvantages. The process is click-based and requires manual imports, and it introduces additional complexity on top of CI/CD. Now let's look at the Git-based transport. The biggest advantage is clarity. The state of the branch is the state of the system. Everything is version controlled. We can compare changes using Git diff. We can easily roll back using Git revert. The process is fully automatable. There are no manual click steps. Auditing happens through pull requests. Git becomes the single source of truth, not the runtime system. This approach scales very well across cloud and on-premise landscapes. It also allows very fast hotfix directly to production. On the downside, it requires a disciplined branch strategy and it requires solid Git knowledge. But in modern cloud development, this knowledge is essential anyway. Now, let's look at the difference in handling. On the left side, we have cloud transport management. The process is click-based. We navigate through web interfaces, select transports, confirm imports, and wait until each step is completed. A fully transport across all systems requires multiple manual actions and waiting times. On the right side, we have Git-based transport. The process is comment-driven. With only a few Git commands, add, commit, push, we can trigger the complete transport flow. No clicking through landscapes, no waiting for manual approvals in tools. The pipeline runs automatically and deploys to the target system. This makes the process faster and more streamlined. Another difference is tracking and transparency. On the left side with CTM, visibility is limited. We can see the transport status, but detailed analysis often requires manual downloading logs. The information is distributed across different tools. On the right side, with Git-based transport, everything runs through the CI/CD pipeline. We can monitor the job in real time. All logs, all steps, and the full deployment history are visible in one central place. This makes troubleshooting and tracking much easier. Another important difference is determining the current system state. On the left side with CTM, this can be complicated. We have to check transport logs across different CTM nodes. We need to analyze which transport was imported into which system. It is possible but very complicated. On the right side with Git-based transport, it's much simpler. The branch represents the system state. With a single command git log, we can see exactly which version is deployed. The system state is transparent and directly traceable in Git. Now let's compare the configuration effort. On the left side with CTM, the setup is more complex. We have to configure multiple services in different areas on SAP BTP. This includes destination, Servicekey, CTM landscape node, CI/CD integration, and role assignments. Because configuration is distributed across several tools, the risk of misconfiguration is higher. On the right side, with Git-based transport, the setup is simpler. Typically, we configure one CI/CD job per system. The branch defines the target system. The difference are mainly the branch name and the target space. This means the credentials. Overall, the configuration is more streamlined and easier to maintain. Let's also compare the required components. On the left side for CTM, we need several elements. We need Git, GitHub, one CI/CD job, additional destinations, the Cloud Transport Management Service, a Servicekey, custom roles collections, and defined transport nodes. This increases architectural complexity. On the right side with Git-based transport, the setup is much leaner. We need Git, GitHub, and typically one CI/CD job per system. No additional transport service, no nodes, no extra destination for system-to-system transport. The architecture stays simpler and more transparent. And my recommend. To conclude, I clearly recommend use Git-based transport. The configuration is simpler, the maintenance effort is lower, and the detailed usage is much more efficient. The advantages are not limited to deployment itself. Git provides powerful tools like git diff, pull request, version comparison, rollback mechanism, and fully traceability out of the box. Unless company or customer policies explicitly require cloud transport management, I would always prefer Git-based transport. In many cases, CTM is requested simply because decision makers are not aware of modern alternative or assume that if SAP provides a tool, it must be used. However, SAP itself recommends Git-based transport for cloud-native development. New technology are more advanced and better suited for modern architectures. And sometimes it just requires explain the benefits clearly to help organizations rethink their approach. That concludes this comparison of transport strategies in SAP BTP. In the next part, we will look at an alternative to SAP BTP CI/CD, the GitHub Actions. This approach can be used for deployments to SAP BTP and Cloud Foundry, but also to on-premise systems. See you in the next part. Thank you for watching. I would really appreciate a like and a follow.